In this tutorial, we're going to continue with randomness, and we're going to generate a whole heap of random numbers, and we're going to do some maths on them. We're going to find out what the mean is and what the median is. So we're just going to do a little bit of statistics. So we have two goals. We need to find the mean of a set of numbers, and we need to find the median of a set of numbers. And before that, we need to generate a set So really, we've got three different tasks to do in this program. So what we're going to introduce this idea of a function. Now what a function is a little bit of code that is called and runs itself. It's just encapsulated in a little packet and it just does one job. Good function does one job. So we're going to have three functions in our code. The first one is going to generate the numbers. The second function is going to work out the mean. And the third function is going to work out the median. So it means we can deal with each of these problems individually. We don't have to think of them all together. So let's just deal with the first one. Generate a set of random numbers. So this is going to be a function. So function, create numbers, end function. So this is what your pseudocode would look like. Now I'm just going to add the word function to our language. Because it is now going to be an important keyword that we're going to use often. Function. Okay, function. Now what's our function going to need to do? It's going to need to generate a set of random numbers. It's probably going to have to store them. So we're going to need to create an array. Now this array is going to need to be accessed by all functions. So we need to create the array before we make the functions. So let data equal an array. And we don't know how big our array is going to be. So we'll deal with that problem later. So this is init. Now we don't actually know how many elements are going to be in our array. So we might init some type of size variable. And in our create numbers function, because the size variable is declared outside of the function in the main part of the program, we can access it. So we could create a for loop for value equals 1 to size, create and store new random number in data next value. And that's it. So we could run this function and it will generate a list of random numbers for us. So what we're going to do is we're actually going to do this part of the code before we move on, just to demonstrate what this looks like. So over in our script, we need to init a size. So we're going to go let size, and let's just say we're going to choose 100 numbers to start with. Then we're creating a new array. Let data equal new array. Now this time I am not giving my array a specific size to start with, nor setting its values. I'm just creating an array. Now at this moment, this array has no data in it. It's got no data. But that's not going to be a problem, because we can dynamically add elements to it as the program executes. Now we need to create this function. So function, create numbers. Normal brackets, curly brackets. So this is the function create numbers. Now what's inside of this? There's a for loop. So for let value equal 0. While value is less than our size variable, value equals value plus 1, curly brackets. And now I need to create a new random number. Okay, so let random number equal math.random. Now it's going to give me a random number between 0 and 1, but let's make it a random number between 0 and 100, so times 100. Do I want them to be integers? Sure. Math.floor, math.round. So when I round it, that means my numbers could be from 0 up to 100 inclusive. And now this new random number needs to be added to this data array. So when you add something, you push it into the array. So data.push random number. So that will now store that random number in this list. Now if I run this, and I have a look at what's in my data array, it shows me that it is empty. There is nothing in it. It has a length of 0. The reason is because I have not called this create numbers function. So I made it, and it exists in code, but I actually have to call it. So I could call it over here, create numbers. And now I can have a look at data, and it has populated my data. Now I could run that again. I could go create numbers and have a look at data, and now data has 200 elements in it. That's because every time I run this function, it adds 100 elements. Now if I wanted to run this automatically in the code and not have to trigger it by typing over here in the console, I would just call its name, create numbers, save, and that would execute it. And let's have a look at data. And data initializes with 100 values after the function has been called. And so this code is simple. It deals with one particular problem in our program, and it solves it effectively. So let's move on. What were the other things we needed to do? Find the mean of a set of numbers. So the mean is the average. So this is going to be a function. So first of all, we're going to call it a function. Function, find the mean. End function. So what do I need to do to find the mean? Well, the way you find the mean is you add up all the numbers and you divide by the number of numbers that there were. So I might not know how many numbers have been created. Like I know to set size to 100 here, but in future I might set that to a random number. Or if I wrote my program again, I might run create numbers a different number of certain number of times. So I don't actually know how many times or how many values there are going to be. I need to extract that information. So I'm going to initialize a variable called count. And that's going to tell me how many values are in my data array. So initialize count as the length of the data array. So that will count how many elements are in data and tell me. So I have that value. And now I just have to do a loop and loop through my data array. Now there are other more efficient ways to do it, but we're just going with syntax that you are currently familiar with. So let for values equals 1 to count. Now it shouldn't really be 1 to count. It should be really 0 to count minus 1. Because remember, our arrays are offset by a value of 1. So the first element has a value of 0. And the last element, the count element, will have a value of count minus 1. And then I'll have next values. Oh, and I also need a way of storing this information. So init total equals 0. And then I will need to add each value to total. So total equals calculate total plus the data at values. Does that make sense? So that's just going to loop through and find each value in the array and add it up. This is similar to a problem we've done earlier on in this series. And then I just need to print the mean, which is going to be the total divided by the number of values, which is called count. And that's my mean. So let's create that function. Function find mean, let count equal, no, it has to be the length of the data array. And the way you get that is data dot length. So that will go to the data array, and it has this length. And then we're going to let the total equal 0. And we're going to run a for loop. For let values, if I could type properly, let values equal 0. Values is less than count. Values. Now instead of going values equals values plus 1, if I just do plus plus, that is effectively the same as writing values equals values plus 1. It's a shorthand way of doing it. Okay, now total is going to be total plus the data at that point. And then I will console.log mean, and that will be the total divided by the count. And I can just save that. Now create numbers runs, and now I could run find mean. And it tells me the mean is 45.73. But I would want that to run automatically, so down here after I create numbers, I'm going to go find mean. And there we go. So that is my second function. And this is all I need to do. So if I thought there was something wrong in the way I found the mean, I know exactly where to go and find it. Okay, what's the last thing? Find the median. Now what's the median? The median is the middle number when they are sorted in ascending or descending order. So we're going to have a function. It's called find median. And that we will end that function. Now, we have to find the middle number when they're in ascending or descending order. Now, let's just have a look at our data. Our data has all these numbers, but they are definitely not in ascending or descending order. How can we sort them? Well, it turns out JavaScript has a sort method. So we can just say sort data into ascending order. And that will take about one line of code in our JavaScript. It's really simple. So now we can imagine in our head that all these data values are sorted. Now how do you find the median? Well, the median actually, there's two possibilities, isn't there? If there's an odd number, then it's just the middle value. If it's an even number, it's the n plus 1th over 2th value. So that's the formula. We need two values. So we're just going to do the first one. So we need to actually know the number of elements. So we've got that up here. Count. And we need to do one thing if count is even and one thing if count is odd. So how did we work out if something was even or odd? Well, previously we just used the modulo operator and found the remainder. So why don't we do that again? If count modulo 2 equals 0, then this means it's even. Else, we'll do something else if it is odd. And if. Okay, so if it's, we know it's the n plus 1th term. Okay, so if it's odd, we could just do count plus 1 divided by 2. So init median equal median term is count plus 1 divided by 2. And that will give us the median term. I'll go through this. And then I can just read it off out of the array because it's already sorted. So I can print the data median term. And there, it's easy for the odd case. Now the even case, well, it's not so simple. Because the n plus 1 term is going to be, n plus 1 divided by 2 is actually going to give us a value of 0.5. So we need to actually find the value that's less than that and greater than that. Okay, so we have to find two values and average them. So once again, we're going to get init the median term. And that's going to be, say, like 40.5. So we need to find the lower value of 40 and the upper value 41. So we're going to say init lower equals the floor of the median term. So what floor does is it just rounds down straight away. So 40.5 would become 40. And then the upper is going to be the ceiling of the median term. So the ceiling is going to take that 40.5, say, and make it 41. So then we can just find the 40th and the 41st term and average them. So we can just do some maths. So our median, init median, is going to be the lower term plus the upper term and now I need to put them all in brackets because order of operations still applies. Divided by 2. And then I can just print the median. And so this will find the median if I'm even, and this will find the median if I'm odd. So now I can turn this function that's in pseudocode into actual code over here. So function find median. Now the first thing we need to do is sort our data. So we're going to data equals data.sort. Now if all our values were words, this would be fine because it would by default sort them alphabetically. But we can't just run it straight sort. We're actually going to have to add a little bit, and I'll show you why. So just over here, let's have a look at data. Now our data values all here, you can see, are not sorted numerically. They're just random. If I go data equals data.sort, you'll see they are sorted not numerically. All the values that start with a 1 are sorted first. So we've got 1, 1, 10, 1, 0. And 10 comes before 11 because of 1, 1. But 100 also comes before 11 because it's 1, 1, and 0 is before 1. So just running sort like that doesn't work. We actually have to give our sort some further instructions to sort things as if they are numbers. So I'm not really going to go too much into this syntax at the moment. You just accept it and we'll go with it. We're going to do data equals data.sort. And we're just going to go A comma B. So it's going to take two values, any two values, and compare them. And it's going to return the difference between them. Oh, and I forgot to put a closing bracket in. And now when I run that, you'll find that they are sorted in ascending order. So we're just going to do that over here. A comma B, just return A minus B. Okay, so that will sort our data in our program. Next we need to get our count. Now we're coming down here to our selection with this condition. So if count, now remember modulo is percentage, and we're dividing by 2, and if that is equivalent to 0, we're going to do one thing, else we will do something else. So in our first case where it's even, we need to find this median term. So let median term. So let's find the middle value dependent on the length of our sequence. Count plus 1 divided by 2. Now, because it's an even number, we know this is going to have a 0.5 at the end. So we need to create our lower variable. So let lower equal math.floor of the median term, and let our upper equal the math.ceiling of our median term. Alright, so we've done these, and now we need to actually find that value. So let the median equal, now we go to data, and we find the lower one. And then we add data, the upper one. And we have to divide those by 2 because we need to find halfway between them. And then we can just console log and print that out. Console log, median, and we'll add median here. Okay, so that works. Next, for the odd case, we just have to find the median term, so I can just take that. And because it's an odd number, we don't have to do anything else. And so we can just console log the median, which is going to be data median term. And so I could run that up here, median term, find median, and it would find the median. And if I just wanted to run that down here, I could go find median. Okay, so find the mean and the median. But how do I know it's right? How do I know this is correct? Well, let's just change the size of our array. Let's do it something we can do in our head and check. So we're going to make our size 5. Okay, and instead of up to 100, we're just going to make a random number up to 10. So all I changed here was the limit, so it's between 0 and 10, and made 5 numbers. So now I can have a look at my data. So it says my median is 5.8, and my mean is 5.8, and my median is 9. Okay, So let's have a look. Let's have a look at the median. So the median should be the middle number, but it's not. It's 1 to the right. And why is that happening? Well, the reason it's happening is because, remember, our arrays have an offset of 1 element. So we just need to take the median term, and we need to subtract 1 from it. So I'll show you why down here. Okay. Down here, we'll write our numbers 0, 5, 6, 9, and 9. In our array, this is element 0. And this is element 1, this is element 2, this is element 3, and this is element 4. Okay? So this is the value, and this is the element, or the position in the list. Now, the way we found the medium term was to go 5 plus 1, which is 6, divided by 2, which gives us 3. So our third element by our normal counting is this one, but by computer counting it's this one. Okay, so we need to take away 1. So I'll subtract 1 here. And that means I will need to also subtract 1 up here. Okay, and that will correct. So let's have a look now. Run it again. And there we go. Our median is 5. That works. It's all good. That's why you run test cases. You learn to check for the 0th element. And our mean, 5.2, well, let's just add this up. 14, 21, 26. 26 divided by 5 is going to be 5 for 25.2. So 5.2, our mean is 5.2. So we know our calculations are correct. And because we checked, we got the correct value. So now we can do whatever we want. We can go back to a value up to 100, and we can set our array to 100 values, and we run. And our mean and our median are approximately 50, which is what you would expect. If we change this to 1,000,000 and ran that, we find that our mean is almost exactly 50 and our median is definitively 50. So that's what you would expect for a normalized distribution or an equal distribution of values either side. The only data that we haven't actually worked out statistically is how to find the mode or the range, but I will leave those as an exercise for you